Hello guys, and welcome back to another C++ video. Today we're going to look at some more variable types that we didn't discuss previous time, and we are going to look at how they're allocated in memory, and we're going to look at some examples. So let's get into the video. The first data type that we are going to discuss today is the character data type. The character data type can represent 128 different characters, each of which are assigned an ASCII value. These characters include Latin characters such as capitalized A through Z or uppercase A through Z, and lowercase characters A through Z. It also represents numbers 0 through 9 and special characters such as backspaces, new lines, tabs, white spaces, etc. So what are ASCII values? ASCII stands for American Standard Code for Information Interchange. These are encoded values which tells the machine that a certain character is stored in memory. The keyword that we use to represent a character is pronounced either car or char. We spell it as CHAR. And a character is stored in 1 byte as shown in the figure below. So it can hold a total of 2 to the 8, which is 256 different values. But because we need only 128 of these values, each of these 128 values, which are 0 through 127, are each assigned a character type. As we see in the ASCII table here, the first character represented by the ASCII value 0 is the null character. Besides, the characters uppercase A through Z are represented by ASCII values 65 through 90. The lowercase letters, on the other hand, are represented by the ASCII values 97 through 122. Let us continue with our coding example. So last time, what we did was we created two variables of type Boolean, which we named A and B, and then we printed them out using a cout, and what the endl did was it just made a new line. And we did not use the standard and the scope resolution operator because we used this statement called using namespace standard, which included the standard namespace for our code. So we did not have to explicitly write standard scope resolution and then cout. So let's continue. Today, we're going to at first declare a variable of type character. For that, as we saw, the keyword for a character variable type was car, which is written like so. And after we write the variable type, we need the variable name. So for today, we're going to name the character C. And then I'm going to initialize it to a value. So to declare a character, we can either use the ASCII values of the character, or we can write it using single quotes. Remember that characters must be written in single quotes. If you write double quotes, it's going to be something we call string. We're going to go over that later. So I'm going to set this character C equals capital C. And then I'm going to print out the character C to the screen. And then I'm going to make a new line. So I'm going to just build and run from up here. So as you can see, we have the previous values for the Boolean types, which at first gave us a garbage value because we did not initialize it. And then the other one we initialized to false, which gave us a 0. And then we changed both the values to true, which gave us 1s. And then we made our variable of character type and we initialized it to C, so it printed out capital C. So what we're going to do next is we are going to make another variable of type character, and we're going to name it D. And then we want to print out C, like capital C, using the variable D as well. But this time, instead of using single quotes, we are going to use the ASCII value for C, for capital C, which is 67. So I'm going to set this equals 67, and then I'm going to end the statement using a semicolon. And then we're going to output the character in variable D. And then we're going to create a new line. Before that, I'm just going to get rid of all of these. And I'm going to save it using Control S. And then I'm going to build and run. So as you can see, because we initialized the first character C with quotes to capital C and printed out C, but then we initialized the variable D with the equivalent ASCII value of the character capital C, so that outputted capital C as well. So we can either use the ASCII values or we can use single quotes to initialize our characters. The next data type that we are going to discuss is the integer data type. Integers store integer numbers, which are whole numbers like -1, -2, -3, or 1, 2, and 3. The keyword that is used to represent an integer is pronounced int, which is spelled INT. The size of an integer data depends on the compiler and the operating system. But whatever operating system or compiler it is on, the size is either 2 bytes or 4 bytes. Assuming that the data type is 2 bytes in size, which is equal to 16 bits, the total number of different integers that it can store is 65,536, which equals 2 to the power of 16, because we have 16 bits and each bit can hold 2 different data, which is either 1 or 0. The range of the integer data type is from -32,768 to 32,767, assuming that it is 2 bytes. There are, however, some variations to the integer data type. So let's take a look at those. At first, one of the variations of the integer data type is the unsigned integer. The unsigned integer stores only positive integer values like 1, 2, and 3. If a negative value is assigned to it, it will interpret as if the number, the bits, were representing a positive number, and it'll give us a different value than expected. So we should always initialize it to a positive value. The keyword that we use to represent an unsigned integer is Unsigned Int. And because this has a base type of integer, it also depends on the operating system and the compiler if the size will be 2 bytes or 4 bytes. And assuming that it is 2 bytes, the range is now from 0 to 65,535. The next type is a short integer. A short integer is a type of integer that has a definite size of 2 bytes, and it has a keyword of short or short int. We can use either one of them. And because it is 2 bytes, it can be represented in 16 bits, and so the range is like when we assumed it to be just an integer and the size to be 2 bytes, and that is from negative 32,768 to 32,767. And then another variation is called the long integer. The long integer can be represented using the keyword long or long int, and because it can store more integers, the size is 4 bytes, and because 4 bytes is 32 bits, it can represent 2 to the 32 different numbers, 2 to the 32 different integers, which is approximately equals 4 billion, and so the range is from almost approximately negative 2 billion to 2 billion. Some more variations of the integer are unsigned short, which are short integers but only positive ones, and then the unsigned long only stores positive long integer values, and then we also have long long and unsigned long long, which are used for only very long numbers. Now let us look at a code for declaration of integer variables. So at first I'm going to comment integers, and then at first we're going to look at a base integer type, which is declared using the keyword int, and then I am going to name it a and set it equals 32. Then I'm going to make another variable of type unsigned int. Oops, it should be int, and I'm going to set that equals 9. Then I'm going to make a variable of type short, which is a short integer, and I'm going to name it c. Oops, and we didn't name the unsigned int. I'm going to name that b, and then I'm going to create a short of type c and then set it equals 32,000, and then I'm going to create a long, name it d, and then I'm going to set that equals 2 billion. Then I'm going to see out all of them. Just going to copy that, paste, and then I'm going to change the variable names. Then I'm going to save this, and it should print out 32, 9, 32,000, and then 2 billion. So let's build and run. And as you can see, it printed out 32, 9, 32,000, and 2 billion. So let's say I want to take the integer a and then store the value 4 billion in it. So as you can see that if we store 4 billion, if we initialize this to 4 billion, even if this is 4 bytes, it can only hold values from negative 2 billion to 2 billion. So if we store 4 billion in this, it's just going to cut off part of the binary representation of 4 billion, 4 bytes, and then use that data to represent whatever number this represents from negative 2 billion to 2 billion. So if we run this now, it should give us a value from approximately negative 2 billion to 2 billion, and then 9, 32,000, and then 2 billion. So let's go ahead and run this. So as you can see, first we get a value close to negative 2 billion, and then 9, 32,000, and 2 billion like before. So the reason for me showing this is that whenever you are declaring a variable type, you want to make sure that what range of values you want to use, and use a specific type of variable for that range. Well, that's it for today's video. Thank you all for watching. Definitely don't forget to like, share, and subscribe, and definitely hit that bell button to get instant notifications when I upload my videos. And have a good one.